There's no way to actually uh, need for me to be actually reminding you about it. Okay? So, okay, sige, Eliza. I didn't forget about you. For next. Thank you, Eliza. Or Elisa.
Sir, I'll just send the quote muna sa GC first.
Okay, sige. Thank you. Okay. So, Alisa is not forgetting, no? She actually uh, is asking in advance if she's the next. Okay. This is so simple coming from you, no? And you see how we waste time here, no? If we are not prompt, we are not aware of what we're doing, or forgetfully, no? You're still young for you to be oblivious. Okay, Elisa, let's go.
Okay, I'll just present po muna. Okay, so this is my quote, which reads, "The only way to learn mathematics is to do mathematics," by Paul Halmos. From my own understanding, this quote means that basically you can't just learn something simply by looking at the formulas and etc. The way to learn things is by trying things out. And it doesn't just apply in math, but it also applies in our everyday life in with our talents and other subjects as well, which is why Sir Romel probably gives us activities so we can understand the lesson more. So let's pray now po. Dear Lord, thank you for this day that you have given to us, Lord. I pray that we all have a good day today for whatever is going to happen in math. Lord, I pray that for our exams, which are upcoming in the same week than this week, Lord, I pray that we all study in advance and do well in the exams. Thank you. In Jesus' name we pray. Amen.
Okay, so basically we do have 3 days left. No? Thank you for that, Elisa. Thank you. No? Thank you so much. So basically we have 3 days meeting before our periodical is taking place. And then this is the second or no, yeah, second to the last day, no? Because it's Monday and Wednesday that we all meet 1:30 p.m., no? It's a break. There's a break in between, no? After your last subject, and then a break of an hour, and then 1:30 p.m. It is really what do you call this, no? A mode that is a lazy, no? A lazy mode. Why? Because it's a time for us to take siesta. What siesta is, after you take your lunch, you tend to actually go to sleep, no? You feel sleepy. Am I right, Samuel? Yampong? Oh, that's siesta. That is siesta, the meaning of siesta. But next year, that's third quarter, we do not have this anymore, 1:30 p.m. Why? Because your math will be taking place NWF. So that's 11:4 to 12:30. So no more 2 days of having this 1:30 p.m. No? Okay, it's clear to all of you now. And then what else? That's 3 days only MWF, no TTH, no? Okay, so it's clear. Let's go. Can I have your attendance? Okay. Uh, your attendance must be you sending me a message without assignment, with assignment. Okay, so I'm referring to this, no? Okay, so again, messenger me your attendance in the messenger saying without assignment or without assignment, no? And then sige, I'll be seeing the names there, of course, no? Okay. So basically, mathematics again, no? As I've been telling you, this is practice, practice, practice. That's 3 times, no? Not just practice or without practice. And this practice is even actually being reflected in your assignment, no? If you're not doing it, then you are not practicing, no? And then if you notice amongst the polynomial equations or polynomial functions, the basic uh, word problem or the most common word problem that is being actually taken as example there is the volume, no? Okay, it's for the figure, for the dimensions, that is the volume. And for the numbers, it's the consecutive numbers, if you notice, no? So we'll discuss this one. Okay. And then I'll go back to where I ended up um, with you, no? Last Thursday. Okay, the sum of two numbers is 13 and their product is 40. What are the numbers? These are the most basic, no? And there are three consecutive numbers. Their sum is, their product is. It's like that, no? But how do we actually composing the factors of those three consecutive integers? It's there in the textbook, huh? Okay, it's but x, and then x plus 1, and then x plus 2. Those are the three consecutive integers. And you use your polynomial equation, everything, the synthetic, remainder if you want it, factor theorem, and so on and so forth. Be actually finding uh, those integers. So you can find it out in your textbook. Okay, let's have this. The sum of the numbers is 13 and your product is 40. What are the numbers? This one, it's not mentioned that they are consecutive, no? Okay, and then what did you do? Your textbooks, my guide for textbook actually has no solution. I have to solve. First number and second number, it's giving you a sum that is 13. And then first number again and the second number will actually give you the product, no? So it's addition and multiplication. Can you see that? Okay. So first number and second number are to be found. And then you actually uh might, no? Might came across this one having the 13 minus x there, no? Could be for you. It is y, no? Okay, you presented that with y, but it's not, no? We are actually discussing one variable only, no two variables like x and y. Cannot be, no? But that 13 minus x or that y that you might have used is expressed also in terms of that number, the given, the 13. Check, no? If x is the first number, the other number is a 13 minus x. Why? It makes sense, no? You just deduct x that is not known from that 13, and that represents already the second number. That's why it's x plus 13 minus x. See? And then this one. Okay, and then how about the product? It's the same, no? Pertaining to the first and second number, they are the same. Okay, you see the given, no? Their product is 40, their sum is 13. and you're talking about the two numbers. And then, if you notice, if I'm going to be actually taking the polynomial equation of or polynomial expression of this sum, you're having this, no? X plus 13 minus x. And notice how x minus x there would disappear. So this one is not helping you finding the number, no? And then in the product, you see, no? How this one helps you. X times 13 minus x equals 40 gives you this. Okay, it's a polynomial equation. See this one. Okay, and then further, if you want to look for x, then combine them all together, right? This one. This one becomes, okay, notice that negative x squared is a negative, or x squared there, that's having the highest degree raised to 2 is negative. So you have to actually transpose that in the right side. Okay? All left side terms will go to the right side. So you're having this one, right? And it again, I'm saying this always, no? If you were not listening to Mamalaya's teachings, then you cannot find this, no? So basically, this is just by factoring, no? Factors of 40 or 5 and 8. And then that negative 13x is telling you that I should have negative 8 and negative 5. No? Multiply together will give you 40. When you add negative 8 and negative 5 gives you negative 13. Therefore, I'm looking for 8 and 5, no? Or 5. Okay. Make it one at a time, huh? Okay. So if you do not want this factoring, your synthetic division will help you, no? So it's giving us also the 5 and 8. Okay, it's having a remainder that is 0, huh? Okay, so factor of, or the root of this polynomial equation is that 5 and 8. So I know a lot of you got it. And then one at a time, use first, no? Your 8 being the first x value, and then replace them. And then you got 8 as the first number, and the other one is 5. No, add them together, it gives you 13. Multiply them together, it gives you 14. That's simple, no? Okay? Are you listening? Are you with me? Okay. It's simple. And then next, the volume of a swimming pool. Can you read that, John Rain?
The volume of a swimming pool is given to be 3x cubed minus 4x squared minus 28x minus 16. If the height of the pool is given to be x minus 4, what are the dimensions of the rectangular base of the pool?
Okay. Hold back, no? Sorry, hold on. We go back here, no? You see, this is a kind of PE and not PF, not a function. Why? Because uh we haven't used any, no? Okay. We didn't use 0 being replaced by a function of x, no? It's not. Okay? We're merely actually um gotten, or we have gotten only the values of your x there, no? Factoring or SD is helping you there, no? So if you are not converting 0 there as function of x, then there's no way it's a polynomial function, no? It's not. So this is polynomial equation. Here we go here. So in here, swimming pool is actually in a dimension, or in this one, no? X cube. Okay, 3x cubed, that's the leading coefficient. It's telling us that there are three sides, no? Okay. There are three sides of volume, no? When we pertain for volume, it must be the three dimensions, not two, because it's area, so it's two. Okay, let's go. So this is the given. Okay, if I were you, class, huh? You try the word problems there. Okay, I'll give you the answers of the word problems there. Okay, so height is given, no? X minus 4. So out of this three dimensions, or these three dimensions is the representation of this, no? Okay, and then out of this, height is given. And then what are the dimensions of the rectangular base of the pool? Okay, so if you want to illustrate this, no? This is not new to you. This is a pool. So there's a height there, no? So if it pertains to rectangular base, then it must be a rectangle, no? Height is uh what do you call this one? Get rid of, no? Or it's given really, and you're not to look for it. Okay, x minus 4 is there. How do you do it? Okay, so write as much as possible as you could, no? If you want to analyze it. So this is the polynomial equation, this one, and then I'm actually converting it to the function, no? V of x. Okay, let's find out, no? And then it says there, x minus 4 is there already, no? For height. Still, there's a volume there. Okay, so for this one, it's giving me a total already that x minus 4 is but a binomial, no? Okay, x minus 4 is actually giving me a root, no? What is the root in x minus 4? It's positive 4 or negative 4? Okay, let's find out in the USD, no? It is but x minus 4, no? Okay, 4 is positive there, no? And then you have to have the coefficients of those polynomial equations, these ones, and then if you check it, it gives you a remainder that is 0. It really is a root, no? From x minus 4, 4 is really a root. Therefore, x minus 4 is said to be a factor of that polynomial given. And then you're trying to be actually looking for the other dimensions, no? Okay, check, no? There is no certain dimension for those dimensions, no? Okay, measurement of dimensions. There's no given, no? So you do not force yourself, no? I taught you that before, no? You do not give the answer for your teacher, math teacher, specific number or measurement or real number if it's not given in that form, no? It's not, no? Remember, we're talking about mathematics since you were studying mathematics since grade 7 up to now, no? Algebra is being taught to you. So better to know how algebra works for you, no? So this one is algebra really, no? Okay, a polynomial given a binomial that is polynomial. There is no number there, no? So expect that the dimensions of the rectangular base is also expressed in the polynomial. Okay? So others are actually asking me, no? It's good, no? Rather than um, solving this problem without asking me and then silently blame me. No? So this 384 is left there and you're trying negative 2, no? Okay, when you try negative 2 out of 4, rational root theorem, huh? Remember, 4, okay? From 4, the rational root theorem, negative 2 is possible. Okay, and then gives you 0, then 3 and 2 is left, and then 3x minus 2. Okay, this one, no? You must know how to transpose. Then x is equal to negative 2 over 3. And then you say that in here, aside from x minus 4 that is given, factor that you got here is x plus 2 and x plus 2 over 3. Okay? So roots are 4, negative 2, and negative 2 over 3. But these roots are not the one that you're going to be answering me, no? Okay, but they are the factors. Negative 2, what is the factor? It's x plus 2. Negative 2 over 3, the root, what is the factor? It must be x plus 2 over 3. Okay. That is so simple, no? So we didn't actually have this one. Okay. So I'll change this. Okay. Okay. Or if you want to actually use that one and it becomes a polynomial function, wait, no? The factor theorem and or remainder theorem works for that one. Okay? Okay, after having 4, you try 4 there, no? And it gives you a 0 value, no? And then when you try negative 2, is it a negative 2? Yes, a negative 2 for this one, no? Okay, if you want this one, no? And that becomes a function. For me, I never tried remainder or factor theorem. That is why this one is just an example of polynomial equation. Okay, sige, thumbs up. Okay. By the way, no, if I am to be actually doing a textbook for you guys, no, there is no big difference about what a polynomial equation is and a polynomial function is. They do not differ actually, no? It depends on how to use them, no? A lot of theorems are supporting those polynomial functions and equations. It depends on you, on how you use it. Did you get it? Okay, now next. Okay. So I replaced there already, no? We got x plus 2 and 3x plus 2. Okay, so I even converted this one, no? This x plus 2 over 3 should be multiplied, these two terms, by this denominator. Multiply 3 times x, it's 3x, multiply 2 over 3 by 3, gives you a 2. So this one, no? Or you, I can consider this one. Next, okay? Kindly read, Alisa.
Suppose you want to increase the dimensions of a 3 by 4 by 5 CU deep box by a uniform measure. If you want the new box to have a volume that's 3.5 times the volume of the original box, what must be the dimensions of the new box?
Okay, thank you. So your attack here that I observed your assignment, no? Okay, I'm not actually underestimating you, but you got your point, no? But of course, to solve your assignment the way that that is presented there in your textbook, no? Must be. Okay, let's go now. What do you notice? Oh, this is the one that I'm telling you, no? Three numbers that are consecutive to each other, no? Okay, you see this one. 3, 4, 5, no? What do you observe with those numbers? No, it's increasing. So therefore, they're consecutive to each other, no? 3, 4, 5. What is the number after 3? 4. After the 4, it's 5, no? They are. Okay. Easy, no? If we're talking about polynomial function and equation, then we must represent those. If not, nako, mahina kayo sa math. Okay, let's go. Original volume is this one, and new volume is this one, right? And then it's telling us there is but 3, 4, 5 there, no? But I want to represent that. How? Okay. So I want to represent that having my height, no? As my x, and then x plus 1, and then x plus 2. My width and length, respectively. Okay, what happens? Okay, you check, no? So 3, 4, 5, I represented that one. Okay, 3, 4, 5. But that is given, no? But what you're going to be actually finding is the effect, no, of a new volume, because of course, multiplying 3, 4, and 5 together will give you a volume that is the original volume, right? But the given is if you're going to be actually multiplying that original volume by 3.5 times, of course, the dimensions will increase. Okay, what are you going to be actually doing? Okay, this is my representation, no? I'm going to have this, no? X plus 1, X plus 2. Remember, it's a volume, no? And then this one. Okay, notice the 3, 4, 5 is not tantamount or equal to 210. They're not equal, no? Okay, 3, 4, 5 is actually, what's that? 12 times 5, it's 60, no? This one, original volume actually 60 there. If you're not using 210 in the volume here, no? Or in this one, will actually give you, no, the dimensions, the exact dimensions. And then there's something wrong. Okay? So I applied this one in here, and then take note, no? This one now is a function. V of x has has what do you call this one? A number, no? Representation there in that statement. It's 210, it says, no? Saan na yun? Ay, wala. Wala pala. There's none, no? Okay. There's none. Okay. 210 is, okay, basically multiplied, no? I basically multiplied that. Equals 3.5 times 60, no? Okay. Notice that Sir Rommel actually multiplied it now, no? 210 is, it seems that 3.5 is not uh, directly seen in 210. Okay, but why did I multiply it? The statement is telling us so, no? That from the original volume, it becomes bigger, no? By 3.5 times. So therefore, that 60 should be multiplied by 3.5. Are you learning? Are you listening? Okay. Naiintindihan ba ang sinasabi ko dito? Nagsasalita na ako ng Chinese. Okay, sige. Okay, that's why it's 210, no? Okay, though this is not given, you try to analyze. Okay, and then this one is not really a violation, no? X times X plus 1, X plus, it's not. Because it's referring to actually 3.5 from the original, no? It's just that it's being represented in this polynomial. Okay? 3, 4, 5 were represented. And actually, if they're multiplied, it gives you the new volume, no? The same, no? Let's check. Let's really find out, no? If the 3, 4, 5, 3 by 4 by 5 is really increasing when you increase 3.5. And is it the same? Is it the same consecutive? Sorry, is it the same three consecutive numbers but different numbers? Okay, let's check. Okay, so I have this polynomial is helping me, no? Foil and then multiply this one. I'm having this. Okay, so 210 there must be transpose, and then I have it, no? And then this one is helping me. See, this one now works, huh? The function works in here, no? Function of x, 210 volume. V of x here, or function of x here in the V of x means you have to apply the polynomial function. There's a value. Okay? Okay. Let's go. 132 negative 210, no? And then I'm trying 5. Okay. So 210, no? Divisible by 5 or by 10, no? If you want it. Okay, and then 5 works. And then you check, no? Okay, the others, you do not anymore get the value of x. No? For as long as you have the first value, then you try now. No? Okay, if that 5 as the first number is the value that you are really finding. No? So for these ones now, this one, no? X, representation of height, this is width, this is length, you check. Okay, 5 being my height, and then replace it by 5 that those x there, and then you see what you get. No? And then if you multiply this, you check they tally to that 210. So therefore, 5, 6, 7 are the dimensions. Okay? Naintindihan? Okay, I'll give it to you, no? Mamadali lang ako. Okay, naintindihan ba? Okay, yung mga magiging engineer dyan, ha? Huwag masyadong complicated ang iniisip. Kasi kung hindi, hindi nyo maintindihan ito. Okay, naintindihan. Malinaw naman. John Rain. Okay, sige, let's go. So don't worry, I'll give this lecture to you, okay? Okay, once you have the dimension there or the root there from the polynomial equation, coefficients, and then you can say that that first root is the value of x, and then replace everything, okay, from here. Okay, so again, this is 3, 4, 5. This is fundamental, basic, and it's always running, or what do you call this, occurring, no? As as the word problem example for polynomial functions or equations. This one, huh? Consecutive numbers. Remember that. And then lastly, this one. Okay, let's have Emil. Sakit sa ulo nito. Okay, let's go. Emil. Emil.
Hello po, sir.
Hmm.
The length of a rectangular field is 5 feet, more than its width. A pathway is constructed around the field with a width of 2 feet. A. Write a polynomial function that models the area of the field with the pathway. B. What is the area of the field alone if the rectangular field, including the pathway, has an area of 176 square feet?
Okay. So I think it's hard really for you, no? This is complex. Okay, but if you're going to be actually writing or you draw an illustration for this problem, then it will be easy, no? Okay. So it's not a complicated figure, but it's just a rectangle, no? Rectangular field. We're talking about a rectangular field there, no? So this is my representation, no? There's a pathway, no? Okay, there's a pathway. And there's a field there, no? This is the rectangular field. Okay? So it's x plus 5 because it's 5 feet more, no? Then it's width. What is width? It's x. Must be x. And then this is the width of the pathway, no? And then the first one being asked, it's polynomial function that models the area of the field with the pathway, no? So that white one is the field, rectangular field. And this gold one is the pathway measurement. So if you're going to be actually doing a model for that one, a polynomial function model, this one, no? Okay. Area of the field with the pathway, area, no? 8 represents some area. So it's basically two dimensions, so two um, polynomial only, no? So what are they? X plus 4. Where did you get that x plus 4, no? Where are you getting this one? This is x, and then with here it's 2 and 2. 2 plus 2 is 4. And then x plus 5 is the length, no, of the rectangular field. But, okay, we're modeling it, no? The whole of them, no? The white and the gold. It's x plus 5, and then another 2. So it's x plus 9. So therefore, your answer must be multiplying both together, it gives you x squared plus 13x plus 36. That's the answer. As simple as that. Naintindihan? Okay. Naintindihan? Naku, baka yung iba tulog na. Tulog na, Simon? Hindi, okay. Bibigyan ko kasi kayo ng quiz. I'm discussing this, no? An offline quiz about these two, these four. Okay, sige. And then, the next is what's the area of the field alone of the rectangular field, including the pathway, is 176 square feet is square feet. Okay, sige. Okay, so we're talking about the area now, no? Okay. It's asking what is the area of the field alone, no? The white alone. If the rectangular field, including the pathway, I'm sorry, okay, given is the area of the rectangular field. And then it's talking about this one, no? This area. If 176 square feet is the area for the white one. Okay, sige, let's go. Area of the field. Okay. We know that area of the field is x times x plus 5, no? And then given, okay, we already have this one, the area of the white one, the rectangular field, and the pathway, no? This one, coming from here. Okay, now we are looking for the whole field, including the pathway, no? Okay, how do we do that? Okay, so 176 is the area for, again, no? The pathway has an area. What is the area of the field alone with the rectangular field, no? Rectangular field is talking, we're talking about the white one, no? And then the field is, okay, let's have it. Okay, so this one is rectangular field alone, ha? Saan ba yun? Parang mali-mali naman to. Okay. Nahilo na rin ako. Sorry po. Okay, so the golden and the white has 176 square feet. Ulitin natin. What is the area of the field alone, no? The white alone. Okay. If the rectangular field, the whole, including the pathway, the bigger one, no? We're talking about this one, is 176. That's why I made use of this, no? Area of the field with the pathway is this one. I used that. And then it is equivalent to 176. And then I have this polynomial function or polynomial equation. Actually, it's polynomial function, no? Because a of x there, function of x worked. It's equivalent to 176. And then, okay, you have to find an x value there, no? 130 negative 140. 140 is divisible by 7, no? Rational root theorem. And then it's x is equal to 7. Okay. So therefore, the area of the field is x. Value of x there. Okay, it's this one, no? Okay, area of the field will be x value and then x plus 5, rather, it's 12. Okay, so area of the field is 84 rectangular field, the white one. It's 84 square feet only. Okay, whereas that for x, that is but 7. And then for that x plus 5, this is 12. 7 times 12 is 84 square feet. Okay, that's the letter B. Did you get it? So solve for x coming from that. Okay, who got this? Wala. Okay, so I'll give you that, okay? Don't worry. And then give me 4 minutes. Sorry po, naghahabol ako. Okay. So for this one, I know, no? We'll continue this formula tomorrow, but I want you to be actually exploring this. I gave this to you in your GC, okay? Okay, so for this one, the formula there, just press the F2, no? Of your keyboard, that's function 2, no? You see, the keyboard also has function 2, it says, no? Okay. And then this one is an example of the intermediate value theorem, and I know that a lot of you, no, have studied this, no? So for this function, it has 4 raised to 4 degree, so there are 4 zeros. And notice that for that intermediate value, it says that, okay, if there is those function of x, its value of y in this gold, okay, notice that values there are changing in signs, no? 0, -12. There's a change in sign. Then 12, -20, and then -40, 0. Okay? Intermediate value theorem and location principle is telling us that if you notice that if there's signs there, those numbers are really approaching x-axis. No? Remember that function of x is the value of y, no? That if you actually they move towards x-axis, they vary in the signs already, no? They approach 0, and therefore, see this one, no? -12 is approaching 0, no? And then becomes 10. Okay. Between -12 and 10 is 0. See? Okay. And then this one also, it's -42 and 0. Okay, it's there. -12 and 20, it's approaching 0. See? Okay. So it means to say that this gold here are the values of your function of x. It's x-axis, sorry, y-axis value, huh? Y-axis value. Oh, they slide also. Okay. Notice, no? If you do have -2, what happens, no? If -2 is the value of your x-axis, then they will meet there, no? -2, 0 in that point. And then -1 in the 12, 0, and then 10. Now, somewhere in -12 and 10, between -1 and 0 x-axis, okay, there is a 0, this one, no? Value. -1 minus square root of 2 or 0.41. Okay? So it's clear there, no? It's here. Okay, you see. Check that. And then this one also, if you read this, okay, so because I'm enough here now, no? The upper and the lower bound theorem only will be actually determined if we apply synthetic division and only and no more, no less. Did you get it? Why? Because we are evaluating the coefficients, no? Okay, these are the coefficients, and if you divide it by the divisor, and then you get this quotient and the remainder. Okay, these ones are the quotient up to the remainder. And then you notice the signs there, no? Okay. This is the only process wherein we can determine the upper and the lower bound there, no? It's bounded, no? Actually, these value of roots are the upper and the lower. This is the lower, this is the upper. Okay, that's violet. And you see they're enclosing those zeros, those roots, no? They are but -2, this one, and then this one, and 5, no? They are enclosing. They're in the boundary. What are those boundaries? It's 6 and 5, okay, coming from this. When you see this alternating and these all positive signs, okay? Okay, that's it for today. So evaluate this also. These ones are in your Excel. Okay, that's it. Naintindihan? Okay. Sino ang hindi nakakapagbukas ng Excel? If you cannot open, or if you are not your cell phone, you're not so using cell phone or laptop, but your laptop must have an Excel or your desktop. Why? Because in the periodical, I'll tell you now, no, we will graph. Okay? Okay, sige. I'll announce what the offline activity is for today in the GC. Participate it and do it. Okay? For 10 points. Okay, bye-bye. Thank you, class.